The testing assistant, Leah. Yeah, she texted me and said, he's here. All right, so a couple of things. Didn't realize that I didn't post Thursday's notes until just now from last week. So I did just post Thursday's notes. We are down to a handful of days, y'all. I wore this for y'all. Not gonna say anything, but it's this time of the semester. I saw this and just had to buy it for y'all. Okay, this is y'all. Now we are. Let me pull this up. We really. Pen's not working. There we go. Now we go. Okay, so I know they're just ticking away, y'all. So this week we have today and Thursday. Next week we just have Tuesday. The following week we have Tuesday, Thursday, which means we're down to 5 classes counting today. 4 classes if we don't count today. Okay? So we have 4 classes after today, and then your final exam, and that's it. We're getting down to the nitty-gritty. Okay? So a full week this week, half a week next week, a full week the following week, and then your final exam, and that's it. Now, test is over for the last chapter. I have printed them out, but I haven't gone through everybody, so I will email you when I get that done. Remember, I do have that still standing on the table, that if you show me your registration, I have you down. If you show me your registration for spring, I will add 8 points to your lowest test grade. Right now I have Simone, Josh, Naya, Amy, Kelsey, and Amani. So just stop by after class or before class and show me it can be on your phone or it can be paper. Just show me that you have registered for spring semester, and I will add 8 points to your lowest test grade. Okay? So that's kind of where we are right now. What we have left to do is we still have some homework, 1 more test, a little bit of homework, and the final exam. Okay? So homework, a test, homework, and final exam. But what we're doing right now is not as bad, I don't think, as what y'all were experiencing in probability. We had finished up, and if I go into my homework for a second, we had finished up, we had done 2.4, which was that blue sheet. This paper right here. We had finished that up. That was the Germex, linear regression. We had done that going on a date stuff. That is all of the 2.4 stuff. Okay, we had finished that. We had just started probability distributions. Okay, we've got to finish up probability distributions, and then we've got to do normal distributions. So that's really 3 sections is all this test is going to be on. This is the preview for that. And then this is the preview for that. So it's really 3 main sections with 2 baby previews. Homework? Yeah. Yeah. So we've got that out there. I think I said, I don't remember how many questions I said this next test was. Let me pull it up. Notes, study, handouts and study sheets. This next test, oh, I don't have it up there. But I think I have been sent it. Let me go out there and see. Let me turn this off. I think I already have the test out there. Let me go out there and see how many questions are on this test. I'm almost positive I've already got it done. List questions. This next test is 25 questions. I've already got it done. And this test should not be nearly as hard as what we did on that probability test. Now, when we left last time, we were doing probability distributions, which Remember, I'm gonna pull up this one just to kind of show you. Once it decides to load again. Probability distributions were the L1 and the L2, kind of like a frequency table with the X and the Y, or the L1 and the L2. And the first column had to be numbers, and the second column had to be probability. And the probabilities had to add up to 1, and the probabilities each had to be between 0 and 1, which is like 0 to 100%. There we go. And so this is a continuation of, here it slowly comes, probability distributions. So we are still in 5.1. So this is a probability distribution that we talked about last time. And I gave you several examples and I said, is it a probability distribution? And in order to be a probability distribution, this had to be numbers, it couldn't be words. These had to be between 0, each one of these had to be between 0 and 1. And they had to add up to be 1 or very, very close to 1. Remember that? Now, I did just send you within the last 5 minutes, I did just send you the videos from Thursday. Totally left them in my inbox and forgot to send them. And I am videoing today. Ann was out and asked me to video today. So I am videoing today as well. Now, what we're going to do next is we're going to take this probability distribution and we're going to work with it. We're going to take this probability distribution and we're going to find the mean, the variance, the standard deviation, and the expected value of this probability distribution. Okay? So we already know that it's kind of in a table like L1 and L2. Okay? So we're going to go to our calculator, and let me unlock for those of you who need a computer. We're going to go to our calculator and we're going to enter this as an L1, L2. So in our calculator, we're going to do the stat edit and we're going to enter it as an L1, L2. Where I am. And in the problem, it would say something like, find the mean, find the variance, find the standard deviation, and find the expected value. So this would be A, this would be B, this would be C, and this would be D. So we're going to do stat edit. Stat edit. Clear out what's in there. Put in our data, okay? Now, we're not doing a linear regression. It doesn't tell us to find the R value. It doesn't tell us to give us an equation. It doesn't tell us to give us the line of regression. It doesn't tell us to give us a scatter plot. What it wants is the mean, the standard deviation. So, it wants us to work out the problem. So, when we go to Stat Calc, I have two choices that we've been using in this class. We've been doing 1-bar stats and we've been doing linear regression. Linear regression is that y equals ax plus b, the r squared. 1-bar stats was the mean, the median, the Q1, Q2, Q3. So because I asked you for the mean, the standard deviation, we're going to use 1-bar stats. Now, I have two sets of data. I have an L1 and I have an L2. So what do we have to do? Because I have two sets of data. If I just do enter right now, I am just looking at list 1 and that's it. What do I have to put down here? L2. So because I have two sets of data, I have to say I want to look at list 1 and I want to look at list 2. So let me pull that over. So you've got to make sure that you do L1 and L2. If not, it's only going to be looking at list 1. For the two of y'all, you're going to do the L1 comma the L2. But on your test, you're going to do it just like this. Because the calculators are going to be like this one. Okay? And there's 2 pieces of, remember 2 pages, but the second page are going to be the quartile, 2, the median, the maximum, that kind of thing, but we didn't need any of that. So the first thing it asks for is the median, the mean. What was the mean? What symbol? The first one. X bar is my mean. So my mean is 0.869. This is back to what we've done before, so this is not that bad. I'm adding a little bit to it. Let's get the standard deviation. How do we get the standard deviation? It used to be the SX if we were only dealing with one piece of data. What do you think it's going to be if the SX is not there? And let me show you why. 8, 4, 7. SX is the sample standard deviation. This is the population standard deviation. So they're both standard deviations. This one is if we're doing a little sample. This one is if we're doing the whole population. Okay? So that one's going to be my standard deviation for the whole population. Okay? Now, we have not done variance yet. Variance is super easy, y'all. Oh, yes, we briefly talked about it. If you take your standard deviation and you square it, that is your variance. So we're going to take the the answer below us, which is the 0.7847, and we're going to square it. So we take whatever that answer is and we're going to square it. So my standard deviation squared is my variance. So I'm going to come back, and I only go like 4 places behind the decimal because my math lab, when they tell you to round it, they usually don't tell you to go any further past that. So I'm going to do 0.7847 squared. So my variance, is going to be 0.6158. I missed my decimal there, hold on. My variance is 0.6158. That would be my variance. Now, expected value is brand new. Expected value is what should I expect to happen? Kind of like we did with linear regression when we did that table at the end and said, okay, these are my data points. What if I plug 3,000 into my table? What should I expect to happen? So expected value is kind of the same thing. What should I expect to happen in the future? Or what should I expect to happen with a different data point? Expected value is the same. Let me do it in a different color because I already had red. Let's go with purple. Expected value is the same answer as the mean. So y'all, if the average of the class made up 82 on the test, then I would expect the next person to make around an 82. Because that's what history told me. That y'all made an 82, so the next person should make an 82. They may not. So what should my expected value be? 0.869. Cool? Yes?
Okay, I just wanted you to finish before I ask you this question, but how do I get the L2 to work in mine? Like mine
Go to stat, cal, do, Okay, you're gonna do second L1, comma, second L2.
Okay, I heard you say the comma thing, I was like,
Yeah, and then, in the test, it'll be just like mine. L1 will be there, and you'll just type L2 on the second one.
okay.
Okay? Let's look at one more. It gives us a probability distribution. I want to know the mean, the standard deviation, the variance, and the expected value. So for that probability distribution, I want to know all four of those things. All right, Haley is here. Christasia is here. Ann is not. Brittany Brown is here. Adrian is here. Kiki is not. MJ is here. Amani is here. Billy is here. Josh is not here. Kristen, Candy is here. Naya is here. Amy is here. Jabria is here. Luke is here. Caitlin is here. Ashton is here. Simone is here. Mariah is here. Kay is here and Kelsey is here. So we're missing Ann, Kiki, and Josh. Are you hyperventilating that you're not done with the homework yet? Are you hyperventilating that you're not done with the homework yet? All right, I'm going to do stat edit. Going to type in my data. And because I have two sets of data, I'm going to do stat calc, one bar stats, making sure that I have L1 and L2 listed. Okay. My mean is going to be my X bar, which is 1.48. And my math lab is going to tell you where they want you to round it to, so I'm not too worried. My standard deviation is my X bar. There we go. And it's still my S of X2. It's just according to whether we're doing sample standard deviation or population standard deviation. And then my variance is going to be that number squared. So we're going to do 1.02 to the second power. Am I having the same numbers y'all are?
Mm-hmm.
Okay. Just making sure. So I'm going to do 1.02 to the second power. So my variance is going to be 1.04. And then my expected value is going to be the same as my mean. Cool? Not that bad. So if we can calculate the mean easily, that is what my expected value is. So I would expect it to be whatever the mean is. Now, we're getting ready to do another expected value, but it's not going to be this cut and dry, I give you the probability distribution. We're going to have to make the probability distribution. Okay, so it's going to be a little bit harder, but it's not that bad once I show you a couple. Oh, no, we're going to do something else before we do that. We're going to talk about significantly high and significantly low. A number, and both of these are, if your answer is less than 0.05, we say that it's either significantly high or significantly low. Significantly high is if you're talking about a value or more. So if you're going up the mountain, if it's or more, that's significantly high. If you're fewer, That means you're going low. That's significantly low. But your answer has to be less than 0.05. So if it is or more, that means high. If it's fewer, that means low. But either way, your answer is going to be less than or equal to, so we want the answer to be smaller than 0.05. Okay? It's going to make sense in just a minute, I promise. So if it's or more, if I said you had more than $10, that's going to be on the high end. If I said you had less than $2, that's going to be on the low end. So it's either going to be higher or it's going to be lower. And in order to be significant, it has to be less than 5% or less than 0.05. So now I'm giving you this probability distribution. You're not having to calculate anything. You're just having to tell me the answers. So this is the number of sleepwalkers. It says we have this red, and this is the number of sleepwalkers. And this is the probability that this happens. So the probability that there are no sleepwalkers is 17.2%. The probability that you're going to see one sleepwalker is 36.3%. The probability that you see two sleepwalkers is 30.6%. Three sleepwalking, 12.9%. Go with me? So, the first question says, find the probability of getting exactly 4 sleepwalkers among 5 people. What do you think my answer would be? Find the probability, and y'all, don't make it harder than it is. We're just looking at the table. Find the probability of getting 4 sleepwalkers. This is my sleepwalkers. And this is my probability. This is 4 sleepwalkers, and that's the probability. So 0.027 or 2.7%. Yay? So if I put 5 people in a bed, the probability that 4 are going to get up and walk is 2.7%. Cool? What is the probability of getting 4 or more sleepwalkers? How would I do that? I would add up the 0.027 and the 0.002, and that would give me 0.029 or 2.9%. Yay? So 4 or 5 would be this plus this, which would be 2.9%. What's the probability of one sleepwalker? 0.172. If they want it as a decimal. If they want it as a percent, it's 17.2. Yay? Oh, wasn't a question. I just made it up. 0.363. I was doing 0. Okay. What if I said 2 or 3 sleepwalkers? We would add those together. Okay. Now, which probability is relevant for determining whether 4 is significantly high number of sleepwalkers among 5 adults? Part A or Part B? So, we talked about significantly high. Significantly high meant or more. So significantly high means or more. So with this one, did I do 4 or more? So was part A a significantly high? No, because I didn't say or more. Part B, is that a significantly high? Because it says or more. So this one is going to possibly be a significantly high. So in order to be a significantly high or significantly low, it has to say 5 or more, or 2 or less. It has to either have the or more or less. So this one says which probability is relevant, part A or part B? It's going to be part B because of the or more. Because it says or more, then that means it could be a possible significant high. Had it said or less, It could be a possible significant low. Now we want to know, is it significantly high? Well, in order to be significantly high, it has to be, hold on, let me get my little camera. In order to be significantly high, my answer has to be less than 5%. So what was my answer to part B? Part B, what was my answer? Let me do that in blue because mine was in blue. Part B was 0.029 or 2.9%. Is that less than or equal to 0.05? This is 2.9%, this is 5%, so do you agree that is less than? So because that is less than, it is significantly high. If my answer was 6.2, then it would be significantly, it would not be significantly high. It would just be normal. You're not liking that, are you, Brittany? Now, if this would have said 4 or less, then we would be doing a significantly low problem. And we would take that answer and say, is it less than 5 or 0.05? You with me? Does that make sense? Yes. Give it to me, girl.
I don't understand.
Okay. Let me take this and let's look at a different problem. Let me clone the same problem and let
No.
me just come up with something.
I don't understand how you determine,
If it's significantly high or significantly low,
because it's the same thing. Well,
okay, so if I say, what is the probability of 2 sleepwalkers or less? If that was my first question, how would I get 2 sleepwalkers or less? We would add up that right there, correct? The 0.306 plus the 363 plus the 172. So I would go to my calculator and I would do 363, 306, and 172. So that would be the answer to part A. Now, part B. Would this be considered a significant high, a significant low, or neither?
okay, so what I'm confused about is when you ask that, are you talking about the number or the or list?
I'm asking about, in order to be a significant high, if I give you a bunch of numbers, a significant high is when I talk about numbers or more.
Okay.
A significant low is if I talk about data or less.
Okay.
And anything else would just be between numbers or just a number.
Okay.
Did that just click?
Yes.
So if I use the words or more, this data point or more, then that means I could check for significantly highness.
Okay.
If I use the words or less, that means I can check to see if it's significantly low. But if I say, let's just look at this one data point. I didn't use or higher or low. If I say, look between these data points, I didn't use or higher or lower. So I have to use or less or I have to use or more. We good? Yay? So, in this problem, so, because this problem said or less, I can use significantly low. Just like up here, this problem said 4 or more. That's why I use significantly high. Now, for the part A, it just said exactly 4. I can't use either one. Now, it doesn't matter whether I'm doing significantly high or significantly low. I want to know, is my answer to whatever I'm looking at, the high or the low,